Hello and welcome back to Mr. Adelman's fantastic math class. Today we're going to continue on with our discussion on geometric mean and how that specifically applies to triangles. So we're going to talk about specifically the altitudes of triangles. But before we get into the geometric mean, we need to do a little background with a couple theorems. So the first theorem says that if the altitude is drawn from the vertex of a right angle of a right triangle, so here I've got my right triangle ABC, and I've drawn a altitude from the right angle down to the opposite side to its hypotenuse, so AC. Then the two triangles formed are similar to the given triangle and to each other. So if you look, we have triangle ABC. That is the given triangle. And what they're telling us is that ABC is going to be similar to both, if you look at that small triangle right there, and as well as it's also going to be similar to that small triangle right there. So let's take a look at exactly what those triangles are. So ABC is going to be similar to triangle BDC, triangle BDC, as well as triangle starting here at ADB. Now we're not going to use that specifically, but that is going to directly impact the next theorem that we're going to go over, and that is theorem 7.2. So this is what this most of this section is all about, and so let's take a look at what this says. It says the measure of an altitude drawn from the vertex of the right angle of a right triangle to its hypotenuse, so the same triangle that we just saw, is the geometric mean of the two segments of the hypotenuse. So it's saying this altitude that was drawn, so from B to D, is going to be, well, let's write this down. So BD is the altitude that was drawn from our right angle to the hypotenuse, so BD, and that's going to be the geometric mean between this segment that was formed, AD, and this segment that was formed, let's call it DC. So the altitude is the geometric mean between the two segments, to sum that up. So let's take a look at how we use that specifically. So I've got an example here for you. And it says, so this is example 2, and it's altitudes and segments of the hypotenuse. Just barely fit that in there. And it says that I know that NE is the geometric mean between ME and EA. So let's set up our ratios that we had. So remember that we had A over X equals X over B. And so in this case, I'll put the line segments in there. So A, we can call that line segment ME, and our geometric mean is going to be NE, and that's going to, our geometric mean here is NE, and that's going to go over EA. So let's put in some values that we know and what we're looking for. So let's see, ME is 9. NE, we're going to call that X. And NE is still X again. And then EA is 16. So again, hopefully you know by now that you're supposed to cross multiply. So when you do this, X times X, you get X squared times 9 times 16. And I know that 9 times 16 is 144. So I'm going to take the square root of X squared and the square root of 144. And you may or may not know, but the square root of 144 is 12. So that tells me that the length from N to E is 12 centimeters. And that's how we use the geometric mean to find the altitudes of triangles. Well, thank you very much. That's all we have for today, and I'll hope to talk to you real soon. Take care. Goodbye.